Welcome to the process design and simulation. Today we have a model number 4. The problem statement of model number 4 is a feed stream containing carbon monoxide, hydrogen and methane to produce methanol. In this statement we have three components or carbon monoxide, hydrogen and methane. They will be feed into a reactor and they produce methanol. So the feed stream contains hydrogen 31%, carbon monoxide 67% and methane 2%. Design a process to produce methanol. We have to design a process or a project design to produce methanol. The equation or reaction is carbon monoxide with hydrogen to produce methanol. So this is our reaction. Uh, we have to come up with flow sheet of this process. We will have a rough sketch. One of my student told me about how to draw a rough sketch on a Google Jam sheet. So we will draw a rough sketch on Google Jam sheet. Okay, this is a Google Jamboard. We will draw a rough sketch of this reaction diagram here. On a sticky note, we'll write a reactor. Can change its color. This is our reactor. Make a copy of it. As after reactor, we need a separator in which we separate the phases or components. It is a separator. We can change its color so we can differentiate between reactor and a separator. After this, we need a feed. We'll add a symbol here. Like this. Copy. Make a copy of it. Connect with the reactor with separator. On a reactor, the reactor which we have installed, it can be a plug flow reactor or continuous stirred tank reactor, CSTR or packed bed, depending upon our literature. After the reactor, we installed a separator, and this separator can be a flash or a distillation column or absorption column, depending upon our process. So after reactor, in a separator we will have a product. We'll make a copy of this. Paste it. Adjust these streamlines carefully. Okay. We have having a conversion 100% of conversion of raw material. 100% conversion of raw material. So somehow we have to decide recycle some of raw material for economics. Some of the raw material. Let's suppose we copy this and put it like here. We are adjusting our streams for economy. Some of the streams which are recycled are fed to the initial stream, initial feed or initial feed. We can draw like this, and some of the component we can make a stream like this. After this we can include this stream here. So it is our rough sketch. Okay, we will assign name to all these feeds, all these reactors, all these streamlines by adding a text box. This is called number 1. Make a copy of it. Edit and it's number 2. Another copy and paste it. It's a quite easy and simple to draw a rough sketch in Google Jamboard. Edit this and it is number 3. In a similar way we will make a copy of this. On a right click we'll write it number 4. After this copy and paste. It will be our number 5. Make a copy of it. Edit. It's number 6. And this is our last stream, number 7. So after this, somehow our recycle stream goes into the raw material. We can also fit a heat exchanger and so on other things like this. This is just an overall setup. This is just overall setup of our flow sheet. Okay, we have already assigned the names. Number 1 stream, number 2 to so on, number 7. We got a setup like this. Okay, we have to go now Coco simulator and try to simulate this process. So I will show you on Coco how we will be about come up for the program and how to start this simulation in Coco simulator. Okay, now we will move to the start Windows side. We'll move towards Coco folder. We'll open Coco folder. We will move to the configure TAA. It is TAA thermo edit property package. We will start create template. After creating template, we will assign our project design name. It is methanol production. We will assign a name methanol production. After methanol production, we will select a model set. It is SRK model. We will select SRK model and we will add components in it. We have hydrogen. Double click on hydrogen, it will be added. After hydrogen, we have carbon monoxide. Carbon monoxide, methane, and last one is methanol. These all 4 components with name methanol production, model set SRK, hydrogen, carbon monoxide, methane, and methanol will be added in a TA property package. We'll select OK, and it is similar way. It is methanol production. We'll select done. After this, we'll move towards Coco folder again, and we will select now configure corn. After configuring corn, we will have a bar like this, corn reaction numerics. In this, we will add a reaction in which we will assign a reaction. Let's see how it works. We will create template. It's a general name. We have a same name, methanol production. After having methanol production name, we'll move towards the compounds, and we'll add compounds. We have hydrogen. After hydrogen, we will add carbon monoxide. After adding carbon monoxide, we will add methane, and the last one is methanol. These four components are added. After adding this, we will move towards the reactions and select a create reaction. So we have only one reaction. We'll assign one. If we have more than one reactions, two or three, we can enter here reaction IDs two or three like this. After selecting it is okay, and now we will balancing the stoichiometric calculations. Hydrogen is in reactant side, so we'll assign -2. Carbon monoxide has 1 mole, we'll assign -1. Methane is 0, and methanol has +1. After this is the equilibrium reaction. We'll select equilibrium reaction, and the phase is a vapor phase. We'll select vapor phase and select OK, and we have methanol production and close it. Okay, now we will move to the cocoa, and in this we will move to coffee, COFE. It's windows or a spreadsheet like this. We'll start working on it. We'll move to the settings. Okay, first of all, we'll move to the property package. In property package, we will select add. We have done in TEA, Cape Open. We'll select this. After selecting this, we have entered this methanol production. Select methanol production. Assign property package to the default stream type. We'll select yes. After this, we will move to the reaction packages and add. After reaction package, we have done on corn reaction package. We'll select this, and in this we have made a methanol production and select methanol production. These both packages, after adding this, we'll close this, and now we will move to the flow sheet or spreadsheet. Okay, after having flow sheet, we will insert stream. Okay, this is number 1 stream. We will add number 1 in, we will add values in number 1 stream. Okay, let's we'll have a pressure and its units in system international. It will be kilopascal. Let's suppose we have a 500 kilopascal pressure. We'll insert a kilopascal unit. It will be in, if we select kilopascal, yes, and the let's suppose temperature is 25 degrees centigrade or 298 kelvins. Room temperature will set 298 kelvins. Mole fraction of hydrogen is given. Hydrogen mole fraction we can write 0.31. For carbon monoxide it is 0.67, and mole fraction of methane is 0.02. Sorry, for methanol it is 0, and the rest can be written as. So if we move towards the flow, if we select 100 kilomole per second, 100 kilomole, we can select 100 kilomole per second overflow. So if we like we have put these values like this, and you can see compound flow, hydrogen, carbon monoxide, methane. Why? Remember, we have selected in thermodynamics property SRK model equation of state. That's why they calculate, this software calculates all the values. You can see these values which are given, vapor properties. These all values are inserted by in this software by putting the initial values. So we will have like this interface. Now back to the flow sheet. This is our flow sheet. We have added values in stream number one. After moving to the towards the flow sheet, we will insert a unit operation. Okay, we have a reactor. We will select a reactor. Different or various reactors are given. We will select any of reactor which will be suitable in our process. Okay, we will select Gibbs reactor as we do not know the values of constant or values case. That's why we will select Gibbs reactor. Uh, Select Gibbs reactor like this. Okay, assign reaction package methanol production to unit operation Gibbs reactor one. Yes, we assign these packages to this one. Attach the stream number one and give reactor like this. Now if we select the edit option, we like this to move. It's a isothermal gives reactor. Yes, a reaction defined by we will have we already done a reaction package. We'll select this and it is in a vapor phase. Yes, it is vapor phase. We'll move to the reactions or a reactive component. After operation, it is a isothermal pressure drop. We do not know. Temperature is already we have select that. Reaction package and vapor phase. Okay. We will add the next stream in it. We'll select outlet stream like this and attach this. Now we'll select this edit phase. And in reactions we have add already reaction 1 in previous add this. So reactive we have this reactive components and all other these values. Okay, now stream 2, if we select this and we want to run, the color will be changed like this. Okay, after running this we can add or check stream 2. Okay, in this it is kilopascals. Compound flows, we can see the compound flow is kilomole per second. We can change in any other unit. uh, okay, back to the flow sheet. Now we will add a separator. As in our reaction we have seen a rough sketch a separator. We will add a flash separator. Let's we have add a flash separator. Okay, after this insert stream number. Okay, now we will insert stream in flow sheet. Stream number 3. Connect with it. Connect with the flash separator. From the upward side, it's a vapor, so connect it as a vapor. Insert stream number 4 at the bottom of the flash separator. It will be liquid. So after adding this we can run and check this. It's running, it's all okay. Now in if we see our rough sketch, after separator the feed is moving upward in a vapor phase and the fluid is moving downward, it is a liquid phase. Okay, in upward phase for the economy of the process, we came to know, we made a sketch that some of the stream will be recycled and will be sent back into the initial feed. For recycle we need here to install a separator. So we'll move toward the insert unit operation. We will add mixers and separator. From mixer and separator we will add a separator. This is our separator. We can draw it here, and move into the separator. From separator, there will be two curves or two streams. One of them will be recycled into the feed, and one is moved towards the other end. So insert and connect here. We call it outlet 1. Connect outlet 1 and the other outlet 2. Okay, and connect with this. So from a rough sketch, we can see from a rough sketch, from the separator, one is in the liquid form, other is in the vapor form, and we need here a separator which will separate the for the economy that will move to the initial reaction or initial feed, or here we need a mixer, and the other, on the other hand, the second stream will move the other direction. So after connecting this, we will get a structure like this. Okay. Okay, we will see the conditions of separator. Separator, we can change it according to our desire. Let's for feed number 1, we say it is 0.05 and the other is 0.95. We can say this. It's our separator input stream into number of output streams. Okay, we have mentioned that the only 0.05% will be moved into stream number 5, and the other into move number into stream number 6. After adding these values or changing the parameters, we can check it by run. Yes, it's running. No, now what to do? We have these two streams, number 6 and number 1. We said that we have a recycle stream, and these two streams can see, in this case we put a mixer here so that we can join these recycle stream and the initial feed. By moving towards the inert unit operation, now we will need a mixer. We will select a mixer here, or you can insert mixer here. Okay, after putting mixer, we can adjust our streams like this. Wait, we will move our first stream, yes, like this. We call it inlet 2 and connect these mixer. And okay, after connecting the streams with mixer and the reactor, we can rename our streams. Rename like 1, 2. It is number 3, number 4, number 5. As we have mentioned in our rough sketch, we can rename these streams to ease the and to all process. So we have 7 streams. We click on run button to solve it. So this is our sheet, and it can be, you can see it is solved, and it will run like this. So we the according to our problem statement, which is a feed stream containing carbon monoxide, hydrogen, and methane to produce methanol. We draw we have drawn a process, a fully processed design in Coco Simulator in Coffee flow sheet, and this is our flow sheet, and we have renamed the streams, and we have run this process, and this is our model number 4. Okay, you can see all the values from the streams by clicking on it by reactor. So we came to know about mixer, Gibbs reactor, flash distillation, separator, and all other streams, in which we also recycle some of the stream. So this is your model number 4. Thank you very much.